we're going to do is we're going to do a calculation on gas volumes. And for gas volumes, we need to understand a particular formula. And we're going to refer to Dr. Bourne's triangle. That the volume of a gas equals the number of moles times the molar volume. And if you remember Dr. Bourne, we had to put the units in for the molar volume, so it's 24 dm cubed.
Lovely.
Now, when we actually do a question like this, we have to read the question. It's really important to extract useful information. So I'll read the question first. So calculate the volume of hydrogen gas produced when 2.3 grams of sodium reacts with the water, and we have the balanced equation. So Dr. Bourne, what do we do next?
Well, if we look at the balanced equation and we look at the question, we can see which bits of the equation are going to be important. So calculate the volume of hydrogen gas produced. So that's one of the products, and it's the hydrogen gas when 2.3 grams of sodium reacts with water. So it's the sodium and the hydrogen gas we're interested in. I can then look at the mole ratio, and that's the big numbers at the front. So I've got 2 here.
So that'd be like 2 moles.
2 moles there. And I haven't got a number in front of the hydrogen, so I assume it's 1. So it's 2 to 1. So 2 moles of sodium produces 1 mole of hydrogen.
I think that sounds very straightforward, Dr. Bourne.
Yeah.
Now, in the question, what bits of information are we going to use?
Okay, so now I have to think, do I have 2 moles of sodium? What do I actually have? It says 2.3 grams of sodium. So then I'll have to work out how many moles of sodium that is.
Now, sodium is giving you a mass. So that means if we have a mass of a solid, we need to work out the number of moles. So the number of moles, if you can recall from a previous log, the number of moles is the mass over the AR or the MR. Now, because this is an element, we're going to deal with the AR.
Yes.
Now, looking at your periodic table, the AR of sodium is 23.
It's the bigger number, remember?
And for the number of moles, using that equation or formula, it's the mass over the AR. So it will be 2.3 over 23, which gives you 0.1.
So I now know we've got 0.1 moles of sodium, and because the ratio is 2 to 1, we're going to produce half as many moles of hydrogen. So half of 0.1 is 0.05 moles.
Perfect. Now, Dr. Bourne, does that mean we've answered the question?
Not yet. Go back to the question. Calculate the volume of hydrogen gas. So I've got to convert my moles of hydrogen gas into volume, but I can do that.
Dr. Bourne, quick question. So, if it's volume of hydrogen, can I not use that equation that involved concentration and volume?
No, it's a common error to do that, but we must guard against it because this is not a solution, it's a gas. So we must use our gas triangle.
Right, so it's a gas triangle purely for gases when they talk about volume of gas.
Exactly.
I understand it. So volume of gas is different from the volume of the solution.
Yes.
Perfect, right.
Good. So now let's have a look. Calculate the volume of hydrogen gas. So we want to know the volume. We know the number of moles, and we know we've got to multiply it by 24. So to get the volume, it should be 0.05 times 24.
Here's the calculation I prepared earlier. So that would be number of moles, which is 0.05, is that correct?
Yes.
Times the molar volume, which is 24 dm cubed. And that will give you 1.2 dm cubed.
1.2 dm cubed. Check that the question wants the answer in dm cubed or cm cubed, but it hasn't told you, so we can go with dm cubed, that's fine, and that's your answer.
Well, I think it's still being a gas. What do you think, Dr. Bourne?
Yes.